So for you guys in your Skyward, all the grades should be updated up until your projects. Your project should have been put into. So everything is put in for this quarter, right?
Your notes should help you. If you're having trouble, your notes should help you a lot with answering both these questions.
Alrighty, so we're gonna go ahead and go over the warm-up questions now. So first question says, what is the difference between diffusion and facilitated diffusion? So before we answer that, first I would want to ask someone to raise their hand and answer, does diffusion require any energy? Yes or no? Raise your hand, yes. Don't say it out loud. I'm just talking normal diffusion, not osmosis or facilitated diffusion. No. Diffusion does not require any energy to happen. Does facilitated diffusion require any energy to happen? Yes or no? That's how you shake your head. No. So both facilitated diffusion and normal diffusion do not require any energy to happen. They're both examples of passive transport. So that's a similarity they have, not a difference. Can somebody raise their hand and tell me what they think the difference between diffusion and facilitated diffusion is? Yeah.
Regular diffusion's from like a low to high concentration, and facilitated is through a channel.
So the first part you said about diffusion being low to high is flipped. So diffusion goes from high to low.
Mm-hmm.
So we can also write that note here. High to low. I think what you were thinking of was osmosis, which is low to high. Facilitated diffusion is also high to low. So this is a similarity that both of them also have. No energy and high to low. But the second part you said about facilitated diffusion needing a transport protein is the difference. Normal diffusion happens randomly. The particles are small enough to just diffuse, but with facilitated diffusion, they need a transport protein. And the reason why they need a transport protein is maybe because there's ions or the molecules are too big to where they can't just happen with normal diffusion. So that's the difference. Facilitated diffusion needs that transport protein. An example that we went over is aquaporin, if you guys remember, that transfers a lot of water. That was one of them. Okay, so on to the second question. Name and describe the two major types of active transport. So now we're on to transport that requires energy, not passive transport. So what are the two? Yes. So endocytosis and exocytosis. Endocytosis does what? Yeah.
The membrane like folds in and
Yes.
forms a vesicle.
Yeah. The membrane brings things from the outside in by folding, like you were saying. So we have endocytosis. And remember, the prefix endo sounds like into, going in to the cell. And then, as Max was saying, exocytosis. If endo is going into, then exo would be?
Out.
Yeah, going out of the cell. So with endocytosis, the membrane folds inwards. With exocytosis, a vesicle comes inwards and merges with the cell membrane and releases the stuff out to the cell. Cool. So after you guys finish doing the warm-up, I want you to put everything away. You just need a pencil right now. It's not a pop quiz, it's more so just like a way to see where we're at with the material. So all you need is a pencil, no notes, no nothing for right now. Yeah. But you'll have like, it won't be graded like right now. You'll see what I mean.
That looks so
Anybody still writing anything on the board? Yeah, please. Okay, so the paper I handed out to you guys has 3 pages on it. The first one is a cell biology concept tree. I don't know if you guys can tell, but I put this paper together. I hand wrote everything, I did all the lines, so this is courtesy of me. So I try to tailor to what you guys like know in your notes, so it's not just some generic piece of worksheet that was pulled off the internet. So the first page is a cell biology tree. It branches out from the top. We'll go over some of the branching together, and then you'll have to fill in the organelles. On the second page, we have a matching, which you guys will be matching the organelles to their function. And then on the third page, which is the second half of the notes we went over, cell transport. And that breaks into a bunch of stuff, and then you'll define the terms below. So we'll start on page 1 with the cell biology concept tree. So, what have we been talking about for like the past like month and a half? The basic unit of life? Cells, right? So cells would go at the top of this concept tree. And there are 2 types of cells. It branches into 2 sections.
Eukaryotic and prokaryotic?
Yes, prokaryotic and eukaryotic. So prokaryotic is going to go on the left. And then we'll have eukaryotic onto the right. The reason we put eukaryotic on the right is because it branches into 2. There are 2 types of eukaryotic cells that we've gone over.
plant and animal cells.
Yes, plants and animal cells. Put plants in the left one. And animal cells in the right one. Okay. And then what is the really only type of prokaryotic cell that we've gone over, the example?
Bacteria?
Yep, bacterial cells. Okay. So all of these fall under cells, bacteria under prokaryotic, plants and animal cells under eukaryotic. we have a whole list of organelles that you guys will try to see how much you know. And then the matching here. And then we are now going to fill out a little bit of the cell transport concept tree together. So at the top, right, cell transport. So we went over kind of this idea in the warm-up a little. What two types of cell transport are there? There's one that doesn't require energy, and there's one that does require energy. Give me one.
Active.
Active. And does that require energy or no?
Yeah.
Yes. So we'll put active on the right side. And the other one, which doesn't require energy, would be passive. So as you can see with the tree, or if you guys can fit transport in there, that'd be nice too. I'll just put T for now. Passive transport breaks up into 3 different types of passive transport, which are in your guys' notes that you don't have. And then active transport breaks up into 2 others. And then there's one type of active transport that breaks up into 2 more. So for right now, I am going to give you guys 15 minutes to work either individually or with a partner. I recommend you work with a partner so you both can fill in the gaps of where someone might know more than another about a certain section. And just write how much you know about the organelles, the concept maps, definitions, things like that. Just try to get as much as the worksheet as you can done without your notes in front of you.
Where Rat go with
In a sense, it's like a shell. Because you can, well, also, you guys are going to do their like study. So, if you like had to write down an answer, like what would you write down that you think they do or that you think they know, like if you had to pick? Okay, so if you think that, then like write it down. When the time's you will clarify like what they don't do. So if you think it's the case, then just write it down. I will say to trust your gut. No, I thought it was a lot tighter, a lot more room than it was. How's it going over here? Yo, why are you No! Like, nah, yeah, well, I bet you did. You'll get your but you're supposed to do it. It's okay. At least you don't have your notes for that. That's like that was really I got no idea. I already gave you a message text on his cell phone. No, you'll see when the time's up. I will say it's not I mean, these give you like the words you need for the front. For the most part, there's some on the front and the back on the next, but then knowing the like a lot of the bacteria ones that are not on but yeah, if you don't know what, it's like 6 minutes.
Don't get my top of it.
On my life on center zone.
Stop being.
I feel like
Alrighty, everybody. So, how do we feel about the assignment? Like, how much did you guys fill in? Good, bad, medium? So, how much did we get? Did we get about like half? Did we get a little under half? Over half? A little over half? Half? Okay, so the point is we're at different points, guys. Like, there's things we do know, there's things we don't know. So the point of you guys doing this without your notes just serves as a diagnostic for you guys to do like self-assessment and seeing where you need to fill in those gaps of the information you don't know. Okay? So I'm gonna give you guys like
15 more minutes.
about like 15 more minutes to work on it, but now with your notes. Okay? So you can take your notes out and you can fill in the gaps and change any incorrect information. They're right there. You had your notes somewhere. So look, yeah, no,
Timing of
Who drew that on your? Is that you? Oh, it is. That's like very boring. There's
Oh my.
Like, what page would that be on?
So if you go to the plant cell page, I think it's on 4 or 5. I had you guys star the ones that are unique for plant cells. Or you circled them.
Okay, yes, large central vacuole, so long, 4 pounds.
So it's one of those.
The large central vacuole.
Yeah. But it's not written like that on your paper, it's just written as vacuole because in the description it says plants have a large version of this. Yeah.
No, yeah, no, it's it was basically
Alrighty, everybody. Attention. So, if you guys haven't finished, or if you do finish, I recommend you keep these and work on them while you're at home. You're gonna turn it in on Tuesday, so just use it as study material for your exam. Don't forget, your exam is on Tuesday. We are going to have Jivia review on Monday, and tomorrow we're going to be doing vocab bingo, so it should be fun. Okay?